This is an explanation for every single number type that I know. Even numbers, you know them and you love them. They are the numbers that can be divided into two equal parts. Perfect for tournament brackets, wonderful in arithmetic, pleasing to the eyes. They are
perfectly balanced, as all things should be.
the numbers that cannot be divided into two equal parts are the odd ones. Just like we're children, odd numbers are really unsettling. They literally slow your brain down too. Try adding 6 to 17. Look how long it took you to say 24, and that's not even the correct answer. Composite numbers. Most numbers are divisible by three other numbers, 1, itself, and another number. 6 can be divided by 6, 1, 2, and 3. So 6 is a composite number. Almost every number is like this. However, if you aren't a composite number, then you are a prime number. The only factors that you have are 1 and yourself. Basically, you are the plane crashers or the school shooters of numbers. Really unlikely, but when you appear, you literally mess up everything. Try adding 17 to 59 and you'll see my point.
This is impossible.
Next up, we have the shape numbers. The way these work is that if you could change a number into dots, and then those dots can form a shape, then the number is a insert shape name number. For example, if you take 9 and turn it into 9 dots, these 9 dots can form a square. So 9 is a square number. If you take 10 and turn it into dots, 10 cannot form a square. 10 is not a square number. Square numbers have square roots that are whole numbers. So 9 square root of 9, 3. Square root of 16, 4. Whole number square roots. However, 10 could form a rectangle. So 10 is a rectangular number. 16 is a rectangular number as well as a square number. So it could be multiple types. 9, however, cannot form a rectangle. So 9 is not a rectangular number. And then finally, we have the triangular numbers. So examples of these would be 3, 6, 10, 15. All of them form triangles. Now, it's time for us to push the envelope and move on to more useful classifications. But like I said, I'm going to push the envelope here. So if you don't understand these, it doesn't mean that I'm a bad teacher. It might just mean that you're a little bovine and lumpish. But this is a safe space for idiots, and I will do my best to accommodate you. How many waterfalls do you see in this natural jungle?
1, 2, 3, 4.
How many trees can you see?
1, 2, 3, 4.
Those are the natural numbers. 1, 2, 3, 4, 5, 6, 7, 8. Basic counting numbers are the natural numbers. Whole numbers are the natural numbers, but we put 0 in front of them. So 0, 1, 2, 3, 4, 5, 6, 7. Those are the whole numbers. And if you are keen, you'll realize that all the natural numbers are whole numbers. Natural numbers are a subset of the whole numbers. All natural numbers are whole numbers, but all whole numbers are natural numbers, because 0 is not a natural number. Integers. Integers have all the whole numbers, but they also contain negative numbers. So minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. All of them are integers. Many people find negative numbers scary and might not understand why we have them in the first place. But think of it this way. To measure stuff around us, we need a reference, a universal reference or a natural constant. For example, we measure elevation compared to the sea level, because for the most part, sea level is the same. The Burj Khalifa is 828 meters above sea level, and the Titanic that sunk at minus 3,800 meters. So you see, when you're measuring stuff, we choose a reference, and values above the reference are positive, whilst values below the reference are negative. So, integers are all the whole numbers with their negative counterparts. All whole numbers are a subset of the integers. Rational numbers contain every integer. But now we'll add in fractions and decimals. Minus 5, minus 0, 4, 2, 2.5, a half, 100. All of those numbers there are rational numbers. A number is rational if the number can be expressed as a fraction, Both the denominator and the numerator are integers, and the denominator is not 0. Those are the 3 criteria for being a rational number. 4 is rational because it can be expressed as 4 over 1. Negative 0.75 is rational because it can be expressed as minus 3 over 4. We began with natural numbers, but those are subsets of the whole numbers, which are subsets of the integers, which are inside the rational number. Plenty things like to be inside of other things when it comes to maths.
What did he say?
No, it must stand to reason that if we have rational numbers, then we also have irrational numbers. These numbers cannot be expressed as fractions. So, partner, how will you know when you spot a wild irrational number? Throughout your calculations, surely you have this. What the hell? Throughout your calculations, surely you've seen decimals with a recurring number. For example, 0.333333, or recurring groups of numbers like 0.45454545. These are rational because of the constant repetition. However, if there are no patterns to the decimals in their repeating, such as in the number pi, which is 2.14159263589793223832795028884197, then we have irrational numbers on our hands, ladies and gentlemen. The irrational numbers are not subsets of any rational number, but both rational and irrational numbers are in the group called real numbers. This is uncharted territory for both of us. I present to you complex and imaginary numbers. 99% of the people watching this video didn't know elephants cannot jump. And 99% of the things in complex and imaginary numbers, I don't know, and you probably don't know either. But I can give you an appetizer. Under real circumstances, the square root of a negative number cannot exist. A number cannot be multiplied by itself to give us a negative number, because same signs will always give you a positive answer in multiplication. However, young Padawan, mathematics is about pushing boundaries.
To go even further beyond!
What is the square root of minus 1? I don't know. But to be a square root of minus 1 means that a number had to be multiplied by itself to give us minus 1. Therefore, I say that the imaginary number iota is the square root of minus 1. I or iota, I believe you could call it either one. But like I said, I don't know this topic that much. It's just an appetizer. But I'll go with iota, so we'll call it iota for now. So iota squared, that will give us minus 1. So we made up iota. Iota is the square root of minus 1. Since we established that the square root of minus 1 is iota, I can simplify other negative numbers. What is the square root of minus 12? The square root of minus 12 can be simplified into the square root of 12 multiplied by the square root of minus 1. But we already said that the square root of minus 1 is iota. So that means the square root of minus 12 is equal to the square root of 12 multiplied by iota. Good. So what we did there was create a normal-ish expression. And now we could simplify even further with perfect squares. The square root of 12 is equal to the square root of 4 multiplied by the square root of 3. So 12 will just turn to the square root of 4 multiplied by the square root of 3. And the square root of 4 is 2. So you will put 2 instead right there. So now we fully simplified it. The square root of minus 12 is equal to 2 multiplied by the square root of 3 multiplied by iota. 2 was the square root of 4 and iota was the square root of minus 1. Notice, hey, pay attention, notice that iota is not under the square root symbol. Iota is by itself. So the formula for expressing negative square roots as real numbers is minus b is equal to the square root of b multiplied by iota, or minus b is equal to iota times square root of b, whichever one you want to use. Notice, iota, like I said, is not under the square root symbol. Finally, the overarching complex number theme. All real numbers are complex numbers. They are right here. The imaginary numbers are also part of the complex number group. We put them there. All complex numbers have a form a plus bi, iota. A is the real number part, b iota is the imaginary part. In this equation, if b is equal to 0, then a will remain by itself, and that is equal to a real number. We are accustomed to those scenarios. If b is not equal to 0, however, then the complex number that you have is called an imaginary number. And the final type, if a is equal to 0, that means only bi will remain, and bi by itself, that'll give you a pure imaginary number. And yeah, that's every number type that I know. I guess that's every number type that I know. It's crazy how all of this started from natural numbers, and now natural numbers is kind of like a speck in an ocean, like how small the main world in Hunter x Hunter is compared to that continent, something like that. That's what's happening right now.